Imagine throwing a stone so precisely that it loops around the moon, swings back across the void, and drops into the exact square meter of ocean you intended. Now imagine the stone weighs 20,000 kilograms, and the throw takes 25 days. That is essentially what NASA just did. In November 2022, the Artemis One mission launched the Orion spacecraft on an uncrewed journey farther from Earth than any human-rated vehicle had ever traveled. No astronauts aboard, but every system designed as though lives depended on it, because soon they will. The central question engineers had to answer was deceptively simple. Can we build a capsule that survives deep space? And can we bring it home? Simple question. Extraordinarily difficult answer. Here is the scale that should stop you cold. 694,000 miles. That number is easy to say and almost impossible to feel. So think of it this way. The moon is roughly 240,000 miles away. Orion did not just go to the moon. It flew past the moon, then kept going for another 270,000 miles into deep space, reaching a distant retrograde orbit where the gravitational pull of Earth and moon balanced like two hands pressing equally on opposite sides of a ball. At that distance, a radio signal takes nearly 4 seconds to make the round trip. What surprises most people is that getting far out was not the hardest part. Coming back was. When Orion returned, it was not gently floating home. It was falling. Specifically, it slammed into Earth's atmosphere at roughly 25,000 miles per hour. That is fast enough to travel from New York to London in under 20 minutes. At that speed, friction with the air does not just heat the capsule, it creates plasma. A glowing sheath of ionized gas wraps around the heat shield at temperatures approaching 5,000 degrees Fahrenheit, briefly hotter than the surface of the sun. The mechanism that saves the crew, or save the spacecraft in this case, is a heat shield made of a material called AVCOAT, a honeycomb of ablative foam that literally burns away in a controlled sacrifice. Think of it like an ice cube protecting your hand. The ice absorbs the heat by changing state, melting instead of letting warmth pass through. AVCOAT chars and vaporizes, carrying thermal energy away from the capsule rather than into it. The shield loses mass on purpose so the spacecraft inside survives. But here is what kept engineers awake. Orion used a skip reentry, a technique borrowed from physics and almost absurdly precise in practice. The capsule dips into the upper atmosphere, bleeds off speed, then actually bounces back out into space briefly before making its final descent. Miss the entry angle by even 1 or 2 degrees, and you either skip off the atmosphere entirely and drift into permanent orbit, or you plunge too steeply and the heat shield fails. Threading that needle after 25 days in deep space required navigation accurate to within meters across hundreds of thousands of miles. This is not an abstract achievement. NASA is planning crewed Artemis missions, meaning human beings will ride this same capsule to lunar orbit and eventually to the moon's surface. Every system Orion proved on this flight,